Look at you, sailing through the air majestically, like an eagle, piloting a blimp.
When I'm talking about problem solving, I'm referring to the thoughts and actions that are required for you to achieve some goal that is not readily attainable due to some kind of physical or mental barrier. In other words, something is preventing you from easily reaching a goal, and you have to sit down and actually try to think of a way to get around that barrier. So this definitely involves a decision-making process and creative thought. And we'll talk more in detail about creativity in the next video. But our problem-solving skills are definitely one of the things that really makes us unique. Of all the animals on this planet, we clearly have some really advanced problem-solving skills. So as I just said, decision-making is fundamental to solving all problems. We have to decide on the most appropriate course of action. So decision-making is that process of considering several alternatives and trying to find the best one among them. Now the problem with decision-making is that we would like to think that we, consider all the options, we take in all the information, we compare and we contrast, and we ultimately make the best decision. Well, that's not really the case. In reality, we have what's called bounded rationality, and that just means there are boundaries, there are limits as to how long we can take when making this decision, how much information we have to work with, and so on. So we have realistic limitations when it comes to making any kind of decision. As a result of these limitations, we oftentimes have to make guesses. We have to base our decisions on strategies. We have to take mental shortcuts. You could call them heuristics, or like rules of thumb. So there's a whole long list of different kinds of heuristics that you could use, and that people do tend to use quite often. But all of these are just strategies that we use to quickly identify and evaluate the solution to a problem based on our previous experience. So to put it simply, things that have worked in the past, strategies, techniques that we've used in the past, we will try to apply again in the future to solve similar kinds of problems. Now, obviously, this could be an effective way to solve a problem, but there's really no guarantee that just because it worked before, it's going to work again. There's other aspects that always play a role when it comes to decision making. One of these is intuition. Now, intuition is basically the opposite of logic. Intuition is when you base your decisions on your gut feelings or your instincts. And a lot of people would say this is a good idea because, yes, when you trust your intuition, you oftentimes will be able to make a decision quickly. Unfortunately, because you're not using logic and reason, because you're not really comparing and contrasting your different options that much, there's really no guarantee. It's more or less just chance. You're rolling the dice and hoping that it turns out okay. But something else that definitely plays a major role in decision making is this phenomenon called anchoring. So anchoring refers to just when you overestimate the importance of some particular feature of one of these choices that you're considering, and you really kind of ignore or downplay all the other information. My favorite example of this is when you go to a store and you're considering buying something, like let's say you want to go buy a toaster. So just imagine this. You walk into the store and you see two toasters. One is on sale for $45. The other one is on sale for $20. When you have only these two options, obviously you got to pick one or the other, so most people will probably gravitate towards the cheaper one, the $20 one, because it seems more reasonable, right? Like a toaster for 20 bucks is much, better deal than one for 45 bucks. Most people would agree. But the business types, the people who run these stores, they understand the anchoring effect, so they never have it that simple. They always have it more like this, where you'll have one for $20, one for $45, and then a third one for like $90. So now we have, this extremely expensive toaster, this $90 toaster. It seems completely ridiculous. Nobody should ever spend that much money on a toaster, you might say. But now, simply because they put that $90 toaster on the shelf next to the 45 and the 20, now that 45 doesn't seem so outrageous. Now you're actually going to consider purchasing the $45 toaster, and that's what most people do. People are much more likely to buy the $45 one because it seems to be the most reasonable price for a toaster. I mean, this $90 one is ridiculously high, and in comparison, the $20 one is ridiculously low. So the only one that's actually seems to be, the best deal is actually going to be the one in the middle. And we do tend to gravitate towards the middle in general when it comes to making decisions. So this anchoring is an example of framing. Framing refers to the fact that how information is presented will affect how that information is perceived and can then subsequently influence your decision making. So here's an example of the same information shown in a positive frame and a negative frame. So let's say you go to the doctor and the doctor tells you, we've identified a lump and we're going to have to perform surgery because this might be cancer. Now there's a 90% chance that we'll be able to, successfully perform this procedure with no complications. So there's a 90% chance that you will not suffer or die. Well, that 90% chance seems pretty compelling. Most people would say, yes, I'm willing to take that chance because, 90% of the time I should be able to pull through. So that's a positive frame. The doctor making it seem like it's very likely that you'll be okay. The doctor could instead say, there's a 10% chance you could die from this procedure. There's a 10% chance the procedure could fail. Now that we're focusing on the negatives, now that we're focusing on the bad stuff, people are going to be less likely to take that chance. It's the same chance. It's the same percentages. It's just now we're focusing on the bad stuff, and that's going to make you think about the bad stuff, and as a result, it'll make you less willing to participate in that surgery. So that's just one example. If you want to see a bunch more examples of framing, I've included a link in the comments. Now, something that I like to talk about whenever it comes to decision making is the paradox of choice. And this is exactly what it sounds like. It's a paradox. It's something that doesn't seem to make sense. But here's the basic idea of how it works. So during a decision making period, like when you're considering various alternatives, what we tend to see is that if there are a large number of alternatives, and large could be anything from 4 to hundreds, if there's a large number of alternatives, this is going to produce a proportional amount of anxiety or indecision. To put it more simply, having too many choices is a bad thing. Having too many choices can be overwhelming. For example, you might have a television that has hundreds of channels. If you do, you might find that either you just automatically never consider most of them, or if you do consider all of them, you'll find that you're probably really unhappy and you just constantly sit there flipping through all the channels, never really satisfied. And that's because every single channel that you flip through, you have to make a decision. Like, do you want to watch this, or do you want to try to find something better? So you're always asking yourself, you're always thinking to yourself, there could be something better out there. If I pick this option, I'm basically turning down, hundreds and hundreds of other options. And that's why this paradox of choice can be so anxiety producing. It's because in reality, you're not just picking the one you want. In reality, you're rejecting all the options you don't want. And that rejection can be very upsetting. A personal example from my own life is a few years ago, I went to the animal shelter to get a kitten. Now, when I go to the animal shelter, I see many animals. I see dogs and fully grown cats and other things, but I've already kind of limited my number of choices to kittens, right? So I'm not even considering them. So I go and I look at the kittens, and I see a bunch of cute kittens. They're all equally cute. And I find it incredibly hard to pick the one I want. Because, like I just said, it's not about picking the one you like. It's about rejecting the ones you don't like. So what I found myself doing is picking up the kittens and trying to find reasons to not select them. Like I would pick up a kitten and maybe I'd notice a little piece of poo stuck on his foot or something. And for that reason I'd say, well, not this one. This one seems to have a poo problem, whatever. Or this one has a weird looking spot on his side. And it sounds really mean, it sounds really negative, but that's just kind of what we naturally do. Because it is very upsetting. It is very, stressful to try to always focus on the negatives and reject all of these different options. Now, I have a pretty cool video down below of a speech given by a famous speaker on this very same topic. So if you'd like to hear more about the paradox of choice and why it can be so anxiety producing, you should definitely check that out. But if you're wondering, how many choices, because we need to have choices. If you're wondering how many choices is the best, well, I would argue that it's about 3. So whenever you're faced with a decision, just try to narrow it down to 3 things, and then you'll be relatively happy with the choice that you make if you only have 3 options to consider. My favorite example of that is In-N-Out's menu. They say on the menu, it's as easy as 1, 2, 3. Do you want the double? Do you want the cheeseburger? Or do you want the hamburger? And I think they're incredibly smart about that. People do seem to be quite satisfied, not just because the food is delicious, but they do seem to be quite satisfied with the simplicity of the ordering process. So there's a few different ways that we can attempt to solve problems in life. The most robotic, the most kind of basic way to solve a problem is through mechanical problem solving. This is kind of like trial and error. We just use algorithms, this step-by-step procedure that will guarantee a correct solution, but oftentimes it's extremely inefficient. So you see children doing this when they play with certain toys. I'm sure you're familiar with the little peg game, where the child has to pick up the different shaped pegs and try to put them in the correct holes. Well, when children first start playing with a game like this, they don't really understand how it works. So they'll pick up like a square peg and try to fit it into a circle hole, and that doesn't work. So they try the triangle, try the pentagon, and then finally they find the square, and then the peg goes in and they've solved that problem. Pick up another peg, try again, and so on. It can take them quite a while to solve that kind of a puzzle. But that's just what I mean by mechanical problem solving. Another example from my personal life is I once accidentally locked a briefcase not knowing what the combination for that lock is. So it was a 3-digit combination lock, and I had no idea what that number was. Well, I could have just broken the lock, but it was my father's briefcase, so that probably wouldn't work. So instead, what I did was I literally used an algorithm. I tried 000, 001, 002, 003, and I just kept going and going and going like that. It took quite a while, but eventually I got the right answer. A better way to solve problems is by using your understanding of that problem, understanding of the possible solutions. So you just have like a deeper comprehension of what this problem is all about and how you might go about solving it. So you understand like what the general solution might be. You understand the basic requirements for how to identify a correct solution. So oftentimes when you have this kind of basic understanding, then you can find what's called a functional solution. So that's a solution that works, but maybe isn't, the best. So these kinds of solution by understanding, these are obviously going to be incredibly important when you're dealing with situations where you can't use trial and error. Like, I'm sure you wouldn't want your surgeon to use trial and error to remove your appendix. That probably wouldn't turn out so well. Now, oftentimes when we're trying to solve a problem, if we can't figure out the solution right away, we'll just kind of think about it. We'll go back to whatever we were doing, maybe go walk the dog or wash the dishes, whatever. But we're not really trying to solve the problem anymore. We kind of give up. Well, if after you do that, you have this kind of sudden sensation of just knowing the answer, like it just kind of clicks into place, that's called insight. So insight is that kind of sudden mental reorganization of a problem and the possible solutions that now the solution seems obvious. Like, why didn't you think of that before? You can call it like a aha moment or a eureka moment. And there's been a lot of interesting research as to why this happens. But the basic idea is that even though you're not really actively thinking about it, your brain is still processing that information. Now, there's a few difficulties you might have when it comes to solving problems, the first of which is just having fixations. So fixations refer to our tendency to repeat wrong solutions or just become blind to alternatives. It's almost like you don't realize that you have tons and tons of options. You're just kind of looking at the most familiar options, the options that you have used before but aren't going to work in this particular situation. So having fixations is often the result of placing unnecessary restrictions on our thinking. And these restrictions can come from many sources. It can come from our, emotional experiences. If you feel afraid to try certain solutions because you might be embarrassed or you might be, punished. Like, if you're just scared of making a fool out of yourself, that will definitely prevent you from trying certain kinds of solutions. There's cultural barriers, so just beliefs that are ingrained in our society that pretty much dictate that you are not allowed to consider certain kinds of alternatives to problems. My favorite example of that is in our culture, in the USA, we have strong cultural values for independence. So being able to be self-sufficient and things like that. So if you're ever put into a situation where you simply cannot pay the rent, you cannot feed yourself, I would say you are suffering from this kind of fixation, this cultural barrier to problem solving, if you don't realize that it would be possible for you to move in with somebody else, and then you could share the rent and share the financial responsibilities. You don't have to be independent, even though our culture values that. And then we have learned barriers. So these are fixations that come about due to our formal kinds of education. So this is when you stay with the more conventional uses of certain kinds of objects. I'll go into more detail about something called functional fixedness, which is an example of a learned barrier in just a moment. And then finally, we have perceptual barriers. So these are just habits of taking in information, habits of understanding what's important in the environment that lead to failures to identify appropriate solutions. So one of the most classic examples of functional fixedness can be seen in something called the candle test. So this is just a test you can do with yourself or with your friends and your family, just to see how much they suffer from this particular kind of fixation. So we can test your level of functional fixedness by just seeing if you can solve this puzzle. So here's how it works. You are given some thumbtacks, a small candle about, like, say that big, and a box of matches about like this big. Now, you are required to find a way to attach the candle to a wall so that when you light it, the wax will not drip down onto the floor. So using only the things I just mentioned, the thumbtacks, the candle, and the box of matches, how are you going to attach that candle to the wall so that it won't drip everywhere? Just think about that for a little bit. See if you can find a solution. Now, the most common solution is to thumbtack the candle to the wall, but that's not going to satisfy the requirements of this puzzle, because if you light it, it'll drip everywhere. So what you need to do in order to actually solve this problem is overcome that functional fixedness. You need to realize that that box of matches can do more than simply hold matches. It could also hold a candle. So you could take that box apart, dump out the matches, thumbtack the box to the wall, put the candle in the box, and then light it. So that will basically work like a candle holder. And here's another example, but this one is more so an example of a perceptual barrier. So if you have trouble solving this problem, it's because you're not really identifying exactly what's going on here. You're not really understanding the problem in full. So here we have, as you can see, a bunch of cups. The first 3 cups are full. The last 3 are empty. And the question is, what is the minimum number of cup movements you need to make in order to get them into an alternating pattern? So how many cups are you going to have to move in order to get them into that alternating pattern? Now, the common answer is 2, right? You take the second cup and you swap it with the 5th cup. So now we have that alternating pattern. But 2 is wrong. You can actually do this by moving 1 cup. And the way you do that is you pick up the second cup and you pour it into the 5th one. Like if you didn't realize that liquid is something that you can pour, well, that's just what I mean by an example of a perceptual barrier. And then here's one final example of both a perceptual barrier and a learned barrier. So this also has elements of that functional fixedness I was just testing you on. So with this one, it's called the 9-dot problem. And what you're supposed to do is connect all of the dots using as few lines as possible. So what is the minimum number of lines that you have to draw in order to connect all of these dots? Now there's only one real rule, and that is, since this is on your computer screen, what you're supposed to do is put your finger on the dot you want to start with, and you cannot lift your finger off the screen. So you need to finish drawing all of your lines before you take your finger off the screen. Okay? Or if you want to do it on a piece of paper, just imagine that you have your finger on the paper and you cannot lift your finger until you're done. So what's the minimum number of lines without lifting your finger? Well, the first solution you probably came to is 5, making like a G pattern like this, but that's not correct. You could do less than 5. I'll give you a moment just to try to figure out how to do less than 5. Remember, this is an example of both a learned barrier and a perceptual barrier. So if you don't see a way to do it less than 5, you're not really understanding what I am asking you to do. You're not really understanding the problem. Because you can do it in less than 5. Like here, if you still want to spend some time thinking about it, just go ahead and pause the video. But if you want to see one way to do it less than 5, here it is. So you start here, go all the way to the side here, go diagonally down, back up, and then diagonally through again. Now we've connected all the dots, and we have not lifted the finger off of the screen. But you can actually do it with even less than 4. Here's how you would do it with 1 line. Now, if seeing the solution with only one line makes you upset, that's probably because you thought I said straight lines. I never said anything about straight lines. You could just have one curvy line like this. That solves the problem, that meets all the criteria. If you came up with that solution, good job. Give yourself a pat on the back because you, in this case, literally thought outside the box.